Mission for Vision is a registered charity based in the UK, and we run clinics for optometry in remote regions, predominantly in Africa. And it has always been a concern to us that we have not been able to correct effectively those with high or moderate levels of astigmatism or anisometropia. It was for this reason that we looked into producing a frame and lens system that would enable us to correct complex refractive error in these remote areas where there are no facilities available for glazing optical frames. This is a short presentation to demonstrate how it works. Firstly, it can be seen that the system is extremely portable, fitting neatly into 2 laptop-sized cases, which means that accurate dispensing can be achieved almost anywhere, and it can be done with just a few very basic tools. At the moment, the lens bank consists of around 1200 lenses split between plus and minus powers, with cylindrical powers up to -4 diopters and spheres to plus and minus 14. The hard-coated plastic lenses have all been pre-cut and beveled to fit into the frame, which has been designed for spherical lenses with a diameter of 40 mm. Currently, the frames come in 3 bridge sizes, which offers optical centers of 60, 64 and 68 mm. There are 2 choices of frame color, bronze and the other gold with tortoiseshell rims. The frames have been manufactured with a small locking pin soldered into the inner rim at the nasal edge 2 mm below datum. A slot is then cut into the lens at the correct location to ensure the lens does not rotate once it is in the frame. Once the prescription has been given, the corresponding lenses need to be marked up on a fascimeter with the minus axis running along the 180-degree meridian. The lenses are then put onto a small scale with the axis at the correct orientation, and a small mark is placed on the lens at the nasal point along the 180-degree line. The lenses are then transferred to a small battery-operated device which cuts the slot to a depth of just over 1 mm at the correct point. There is a scale on the device which enables accurate alignment and ensures the correct cylindrical axis is maintained during this process. The frame size needs to be determined by measuring the patient's pupillary distance, and before the lens can be fitted into the frame, the locking pin needs to be cut down to correspond to the depth of the slot that has just been made in the lens. The rough edges must then be smoothed down using a hand file to reduce the risk of chipping the lens. When the pen is ready, the lens can then be fitted by undoing the rim screws and placing the lens into the frame, ensuring the pin fits into the slot that has just been made. Once the lenses are in, the rim screws are then tightened and the prescription is checked. The whole procedure takes about 10 minutes. Here's a short film showing the system in action during our last visit to Mozambique. Right, that's fine. Okay, that's to the nose pads. That's better. Okay, so we've got the very tiny little pins here which will lock the lens in place and stop it rotating. Let's hope this is the left eye, which we're going to do first. Okay, we need to... You can see well. Excellent.
That's the thickness.
Yeah, it's a big difference. Yeah, that's great.
Yeah, scramble
You need a little
Don't let anybody borrow them.
Yeah.
No. Okay, perfect.